Everybody's talking about 3D printing nowadays, that it became an essential skill to have for any maker in his skill set. Welcome to my channel, my name is Zakaria, I'm a mechanical engineer, and I decided to make this video before my simulator part 2 because 3D printing is a very important skill that I used a lot in that project. So without further ado, let's dive into this topic. First, we will start with a brief introduction, then I will explain the different parts of the 3D printer for us to understand how it works and its functionality. Then we will talk about the software and finally start with an example to 3D print here. 3D printing is basically FDM, Fusion Deposition Modeling. The printer is following a certain path, layer by layer, in order to get a full model at the end. I present to you my 3D printer, the Ender 3, the most basic 3D printer you can get out there. It gets everything done and has a really good quality to price ratio. Now, a 3D printer has 3 dimensions. This is the x-axis, this is the y-axis, and this is the z-axis. The motor for the z-axis is on the back. I will show it to you. Now, my printer has separate extruder and nozzle. The role of the extruder is to push filament through, and the nozzle needs to melt down the plastic in order to deposit it. The motors then move this head around and move the plate in order to make any shape you want and any part you want. So this is how the printer will be moving. I will also make a time lapse of a print later on, and this basically covers the main parts of it. The brain of the 3D printer is here. It has the microcontroller and all the things that it needs in here. On the back here we have the power supply. It converts our AC current to DC for the motors and for the microcontroller. Here we have a small screen in order to adjust and change settings on the go, and obviously to start the print and check the temperature, the progress, and so many other things. I will now show you the procedure to start the printer. So basically I just power it on the right and then I will be feeding the filament inside. But before that I need to heat up the extruder. Now that it's up to temperature, I will push the filament from the side, starting by the extruder. As you can see, filament started to pour down from the nozzle. This allows us to change the filament or change the color and many other things this way. We need to do it while the printer is heated. Now I will explain why the printer has 2 fans. The first side fan will cool down the molten plastic so that it becomes strong enough for the next layer to print on top. If the temperature is too high or the fan is broken, many printing problems will occur. The other fan is the most important fan as it cools down the heat sink placed on top of the nozzle. The reason behind this is that we need a really big temperature gradient. Why is that? It's because we must have solid plastic near the nozzle where the print is going to start, and it has to be molten at the point of the nozzle. So therefore we need to have a big temperature difference for us to be able to push filament, solid filament, into the very hot nozzle, or else we will be pushing just liquid on liquid and it will fill by heating up the full tube. This is the bed of the printer. It also heats up and it allows the print to stick to it for us to be able to print different things and maybe have something that's hanging over the side. So the center of mass doesn't have to be necessarily on top of the piece. Some really difficult prints could be done on this. I will remove this part to show you that it's heated. This metal plate will heat up, and this is just to remove the parts when finished printing. I will now present to you some of the things that I made using this 3D printer, and later on we will pass to the next part by talking about the software. Now that you understand how the different parts of the 3D printer works, we will talk about the software. First, we will need two types of software. The first one is a CAD modeler. Just like I explained in a previous video, CAD is computer-aided design. It helps us transform the idea of the 3D object in our mind into a virtual numerical model. We need any software that can make a 3D model. It doesn't have to be necessarily something that mechanical engineers do. It could be something that designers or even game makers or game designers use. Now, the printer doesn't directly understand the 3D model. We need an intermediary software called a slicer. There are many slicers out there, but I personally use Prusa Slicer. The role of the slicer is as the name suggests. It means slicing the model into different layers for the printer to understand. Now, each layer we will first do the walls, and then we will fill in the inside of each layer. Then, step by step, by changing the geometry, we get our model. Since we will not cover the CAD modeling, I will assume we either have a 3D model or we downloaded a model that's available for free online. The first thing we need to do when importing a 3D model is to choose which face is going to be put on the build plate. This is something super important, and a good engineer will think about it when designing the part in CAD before even going to the slicer. To emphasize how orientation is important, this is a part of my simulator. It's the pedal part. This part broke basically because I chose to print it on this side, making layers weak in this direction. As you can see, I have a bolt there, so the stress pressed too much, and with the lateral forces acting on this by the other gear, this part basically broke because there is little adhesion between the layers. The surface of the layer is too small here, therefore they couldn't stick together and the stress caused it to break. Now, the original orientation is best to be precise in the 3D model, because making layers like this would result in poor quality teeth. That's why I first chose to put it like this. Now I will print it another way, which is diagonal like this, but this will require us to put some supports here for the part not to fall when building on the plate. Some models require supports or bridges because the geometry doesn't allow us to print it mid-air. The molten plastic doesn't have enough time to cool down and harden, and that's why we need to make a thinner support layer under it. The advantage of supports is that they can be removed easily after printing. So this is how the slicer presents itself. We have many different settings. I'll first let's go normal mode for now, and import a file. So now we have our model in the slicer. You can choose different settings here, a different filament here, and a printer here. I have a 0.4mm nozzle on my Creality Ender 3 printer. And the dimensions of the bed are exactly the ones that I have in real life. This is called infill. It tells us the density of the part inside. Let's go through some of the print settings. The most important one is layer height. I recommend 0.3 for things that you want to print really fast, and 0.2 or 0.15 if you really want something that's neat and have less of the layer effect. If you don't want to see the layer effect, you can use 0.15 as the layer height, but this will increase drastically the print time. The perimeters here are the number of walls before starting to going to the fill density. Let me explain myself. If I choose this face, for example, and print it this way, I'm going to slice it really quickly to show you. Then the layers will be like this. We can see clearly by zooming in. I chose 3 perimeters, which means that we will make 3 walls on the perimeters. This is actually high and gives me a really strong piece, since this piece has a mechanical function. Now on the right we can adjust and see how our print will go by layer, and in one layer on the horizontal plane we can see the actual path that the extruder will follow. So it will start here and go follow this path little by little, and on the left you can see the G-code generated. It's the code that most machines understand, and basically it tells the printer to go to a certain location and print at a certain extrusion speed. The infill is on a different color because you can choose different parameters and have it thinner or thicker than the perimeters. The solid layers are 2 on top and 2 on the bottom. This means that the first 2 bottom layers will be printed fully. Let me show you this. This is the first ever layer that's going to be printed. There's nothing on the plate. We make the first layer, then we will go to the second layer, which is also full, if I can make it right. But the first 2 are full, then we start making the infill. And that parameter is really important. For the support material, I recommend either grid or organic. The most important thing that makes supports easy to remove is the top contact Z distance. I usually put it either 0.2 or 0.25. Now we will turn the model to print it the way I told you before. We will select the model, then turn it. If we slice it now, we will see that supports are being generated because we cannot print it without support. As you see here, the part will not fail here because the full layer has adhesion and will help in strengthening that part. Now the same force that broke the part before will now face more layers as it is on this direction, and instead of being perpendicular to the layers, it's not perpendicular, which means layer adhesion, which is the weakest part of the print, will not be totally responsible for breaking the part. This will definitely consume more filament, but it helps us strengthen the part. To go quickly over the filament, I am using PLA, and the most important temperatures are the nozzle temperature and the bed temperature. As you can see, it melts at 200 degrees C, and the first layer have a slightly higher temperature because it helps us stick to the bed better. The bed is almost always at 60 degrees C. Here you can also add the price of the filament, and it helps us estimate the cost of the part. This will cost 1.66 in my currency. I recommend you don't change anything in speed or other things, even though you can slightly increase them, but the default values are good because when you choose a printer, it already pre-selects the best settings, or at least some decent settings for your printer in terms of speed and extrusion. What I generally recommend changing is only the style of the supports and the top contact Z distance, as well as the layer height and the number of perimeters and solid layers on top and bottom. These are the only things that I recommend changing. Okay, now that we are happy with our print, we can go ahead and export it to our printer. We will export the file to the SD card and then transfer it to our printer. Look at how easy it is to remove the part once the print is finished. Now that this print is finished, we can finally put it and replace the old one. 3D printing is very useful in prototyping and similar projects. That's why I think it's a really good investment to make. That's all for 3D printing today. We will surely explore this subject further in the future, so stay tuned for the future updates by subscribing, and see you soon.